Hello! Welcome to my house. I'm sorry we didn't get to see each other today, but thank you for finding me on Schoology. I hope that this video will help you as you go back over your reading. If you have any questions after I'm done, find me online, message me on Schoology. I'll be happy to help you over the weekend. But here we go. I'm going to try and keep this short and sweet for you. Alright, here we go. We're going to be working in Lesson 4.2 today, working on experiments and observational studies, primarily experiments though. In your reading last night, it wasn't too long, but there were a lot of definitions. And one of my concerns is that some of these definitions can get a little blurry, sort of like stratified and cluster samples can get a little confusing just reading it on paper, but sometimes talking through it, it can get a little bit better. So we're going to talk about some of the definitions from last night's homework and make sure that you understand how significant these words are and when and how to use these terms. That's going to be the focus of my lesson. Alright. First, if I were to pose a question, let's say I wanted to know whether or not caffeine could influence pulse rate in people. And I'm thinking, just stopping and thinking about that question, that caffeine probably does make someone's pulse level increase, but I want to make sure. I don't want to make any assumptions. There are two ways to justify that claim, or collect evidence to justify the claim. The first is an observational study. The second is an experiment, and each one has its own time to be used. An observational study is a study where no treatment is applied. I'm simply looking and seeing what's already there. Maybe I look at caffeine drinkers and measure their pulse rates. And I look at non-caffeine drinkers and I measure their pulse rates and I compare the two groups. The problem with that is that in an observational study for this situation I'm talking about, there could be other what we call confounding variables. Perhaps people who drink caffeine that I'm going to find are drinking caffeine because they didn't get as much sleep last night as the people who aren't drinking caffeine. And the people who aren't drinking caffeine got more sleep and don't need the caffeine. So sleep hours could be a confounding variable. I don't know if the caffeine is causing people's pulse to go up or if the amount of sleep people are getting is what's causing the change in pulse rate. So to clear that situation up, we would use an experiment. In an experiment, we apply a treatment to the sample. Now, a treatment is just something we do to the sample. In this case, if I want to see if caffeine affects someone's pulse, I would conduct an experiment where I ask certain individuals taking part in the experiment to drink caffeine. I measure their pulse rate before, I measure the pulse rate after, and I can compare those two numbers and see if caffeine made a difference. And if caffeine intake is the only thing that I did to those people, and they had nothing else different from test subject to test subject, then I could say it seems that caffeine is causing an increase in their pulse rate and not some other factor. Such as sleep. Alright, so now we talked about what an experiment is. Just keep a real simple definition in your brain. An observational study is where you don't do anything to your sample. An experiment, you do apply a treatment. You're doing something to your sample. Now that we've got that established, let's go over how to conduct a good experiment. And I'm going to keep using the caffeine experiment just so I'm consistent throughout my lesson today. So with a caffeine experiment, the first thing I would have to do is set up maybe a control. Alright, a control is what it sounds like. For people who have been in science classes, you're familiar with what a control is. A control is where no treatment is applied. I tell people it serves as a baseline to compare our experimental group to. Alright, so I would collect data from my control group, I'd apply a treatment to my experimental group, and then I would compare data. Alright, if there is some sort of measurable difference between these two groups' data, and the only difference between these two groups is that this one got the special treatment, then it would seem that that treatment caused the difference in the data. So here are a few other words I want to go over. Let's see. In the book, you might have missed this, but they talk about explanatory variables and response variables. Let me make sure I've got the page number right on that. I'm not even sure what page that's on, but I know that's in there because I read it earlier. But they've got experimental variables and response variables. All right, your experimental variable is something that you're measuring that you're doing to the experimental group. The response variable is that thing you're measuring when you're done. So the experimental variable in this experiment I'm talking about with the caffeine and pulse rate would be caffeine. The amount of caffeine consumed would be the experimental variable. The response variable would be the pulse rate. I think this is affecting this. So experimental variable, caffeine, response variable, what we're measuring to see if this has an effect on that. So think about it this way. The response variable is responding to the experimental variable. Okay. All right, let's see. We've taken care of all of that. All right, let's go over some more terms. Okay. Your book talks about a treatment. I'm kind of skipping around with lots of vocabulary words from the lesson. Treatment, remember, is what you do to the experimental units. Alright, so let's talk about experimental units. This sounds very mathematical. All it is the sample getting the treatment. If it's people who are getting the treatment, and most experiments that we're going to be studying in this class are we're interested in maybe, like in our situation, does caffeine affect pulse rate? Then the people, they have a special word for that, subjects. Okay, so if you are participating in an experimental trial of some sort of drug and you are receiving that drug, you're an experimental unit. You, the person, are an experimental unit. Not the amount of the drug that you're consuming, not the effects of the drug. You, the person, are the experimental unit. The drug is the treatment. The next thing we need to go over is a little confusing for people. And you probably didn't notice this in the book, but it's on page 238 and 239. The AP test loves to mention these words. Now, I'm really surprised the book didn't highlight them or draw attention to them. But I'm going to take care of that right now. Then we're almost done with what I need to tell you today. There are factors and levels. Let's do that. All right. I think the easiest way to explain this is to give you an example. All right, let's go back to our caffeine experiment. Let's say, to see if caffeine is affecting pulse rate, that I get some different groups of people. Let's say that I have, there's a diagram in your book too on page 239 that's pretty good. So if this doesn't quite make sense, you need another example to look at. Page 239 is a good one to look at. But let's say that I was doing a couple different things. Let's say I had caffeine pills that I gave my experimental units, my test subjects, and then I had coffee. Both contain caffeine, and I want to see maybe if one has a bigger effect on my experimental units than the other. Alright? Another thing I could do is figure out how much of each of these things I want to use. Notice I'm being careful. I'm not saying that these are treatments. I'm going to use that word here in a moment for something else. But let's say the caffeine pill, I had a 5 milligram, 10 milligram, 15 milligram, and a 20 milligram. And then for coffee, I had maybe 6 ounce, 8 ounce, 10 ounce, and 12 ounce. The caffeine pill and the coffee are my two different factors. I have 1, 2 factors. It's sort of like the different things that you're applying to your experimental units, your test subjects. Remember, experimental units are your test subjects. So I have 2 different things that I'm trying out. But I have all these different levels of those things, different measurable differences. So my levels would be 4 different amounts. Again, I've got 2 different factors, and I've got 4 different amounts. Now, to find the number of treatments, there's a formula that I'm going to give you that's not in the book, but this helped me out a lot when I was in statistics. The number of treatments, just say number of treatments, is equal to the number of factors times the number of levels. So if there are 2 factors and 4 levels, this experiment has 8 treatments. One treatment is the caffeine pill being applied at 10 milligrams. Another treatment is the caffeine pill being applied at 15 milligrams. A third treatment could be getting 12 ounces of coffee. But altogether, you have 8 treatments. So if you can draw a grid like this, it's usually easy to see what your factors are because you've had to write them up at the top of your diagram. And it's easy to see what your levels are because it's usually something measurable, like ounces or milligrams. And then you just count them up or multiply. You end up seeing how many treatments are there. They love to do that on the AP test, and that is one of the only things that I would do to improve upon this textbook that we use. This is the best textbook I've ever seen for statistics, but I wish they highlighted this a little bit more. So you've got that now. All right. There's not much more that I need to say right now. There are other things I want to say to you, obviously, but that's probably enough. You probably will have some questions over what I've talked about, maybe things I didn't talk about that were in your reading, because I did not cover everything. But what I'm going to do is stop here and give you your homework assignment. That'll be posted to Schoology along with this video. If you have any questions, find me. I'll be happy to help you. Thanks for being the great group that you are. See you Monday.